All right, here we are. Welcome to Module 3. Now, in the first two modules, we went through the expectations of what you should have brought with you to the class, skill-wise. And now we've been exposed to an introduction to C#, data types that are included in C#, learned some things, how C# different than whatever you've dealt with in the past. Been exposed to, well, let me back up. Chapter 2, Module 2, is going to be the foundation for so much moving forward. So you're going to be referring to Chapter 2 a lot. These first four chapters are sequential. We've got to do them in this specific order. Here's C#, here's data types. Now we're dealing with not just data types, but classes and the different types of classes and the things that go along with what makes one class unique or different than another. There's a whole lot of keywords we're going to deal with in Chapter 3. And then when we get to Chapter 4, it's advanced C#. So it's, all right, we're taking C# and we're going to look at things in a different way. So it's a whole lot of stuff in these first four chapters, modules. All right. Module 3, I had the expectation of giving you two modules together, or in many of the instances in a short summer, or in a traditional 15-week, you get one module per week. Chapter 3, if we were in a full term, it'd be 2 or 3 weeks. At least 2 weeks. In short summer term, Chapter 3 is by itself. And we'll couple together probably 4, 5, and 6 moving ahead, or depending on, just look at the schedule to see how I've got things bundled up. So there's a lot of content, a lot going on in this Chapter 3. In Chapter 2, or Module 2, I had you deal with keywords in the OUT-REF. So that was likely new to you. I said, you've already got GitHub set up. You should have installed some instance of Visual Studio, whether it's Visual Studio Code, Visual Studio.net, whatever it may be. From there, in this module, you're going to write some code and share it with everybody else in the discussion to talk about the different ins and outs of the basics of object-oriented code in C#. I'll talk more about it as we move forward in this lecture, and I may have this Module 3 broken into 2 separate videos, but we'll see how it plays out as we go through it. Here's an example of a basic class declaration. It's about as simple as you can get. We said what type we're creating, it's class. So when you reference it, it's a class, and we gave it a name. Curly braces, opening and closing. Everything that would have happened in there is the class itself. Now, there are a whole bunch of keywords that we're going to deal with that make things that we create, these different types, special. So it could be a data type that I'm creating an instance of, or I've got a special data type that I create. Could be a method that I'm creating. These are different types. Could be a class that I'm creating. That's a different type. So we're creating all these different types. Most of what we're going to deal with is classes, but let's go through and look at different things that are going on in this chapter. And I've got some more supplemental videos, and there's a lecture page that I've got in this module that's got supplemental videos that somebody else has created that breaks this up into smaller sections. So we go through and talk about some things from Module 2 and things from Module 3, and that will help you do what I need you to do in the discussion here in Module 3. Okay? So here's an instance of a class declaration. It's not as simple as the one we had above, but in it, they're declaring a couple of fields. Now, a field it's what we call a variable in a class or a struct. Now, this string called name that hasn't been initialized, I haven't put anything in there yet, we'll call it a field. Now, we know that we've taken database classes, records have fields. Well, if I create multiple instances of an object, or of this octopus class, so I've got, say, half a dozen different kinds of octopus, and I kept track of them in a table, and I said, all right, here's octopus 1 with the name, whatever I want to call it, some scientific name, and the age. I can identify how old each one is. So I'm keeping track of all of the data associated with each one of my instances of this octopus class. It would end up resulting in much what we would see if we had a table in a database. Columns are the fields, records are the rows. Each instance of the octopus class is an octopus object. I give it a name, octopus 1 or whatever we want to call it. And it also has 2 fields within it. And those would have values. Right. So when you think of a variable in the class, it may be called a field. We know it's a variable. You may also hear it called an attribute. They're synonymous. One author may say, yeah, this variable, it's an attribute. It's also commonly called a field. Now, fields allow a bunch of different modifiers. There's access modifier, there's different access modifiers, meaning who has access to it, whether it's anybody, public, only internal, private, nobody has it, protected, whatever it may be. There's an inheritance modifier. There's an unsafe code modifier, read-only modifier, threading modifier. We've always got that static modifier. Now these modifiers, some of them are not just limited to the fields. It could be for methods, could be for the class. So these modifiers we'll see a variety of different types. So, the read-only modifier prevents the field from being modified after construction. Construction meaning once we've created whatever it is we're trying to create. Are you trying to create an instance of a data type? Are you trying to create an instance of a class? What is it that we're going to create that we want read-only? Here's an instance of a string data type. It's static, and it's read-only, so we're not changing this string. It is what it is, and it's getting assigned whatever temp path is, and that path doesn't change. I don't want anybody to mess with it. So we think of static, doesn't change. Read-only, you can't touch it. Non-changing, something you can't touch. It sounds like you're talking about a constant. Similar. We'll talk about that in a little bit. I can declare multiple fields at the same time. Static, read-only. Yeah, they're not going to change. You can't touch them. They're going to be integers. The first one's called legs and the other one's called eyes. Legs gets initialized with a value of 8. Eyes gets initialized with a value of 2. I separated the two actions by a comma, and I ended the statement when I was done with a semicolon. That's the syntax there. So I can declare multiple field values at the same time within a single statement. I just separate them by the comma. Constant is evaluated statically at the time that the code's compiled, and the compiler literally substitutes whatever value in that place. You can't touch it, can't change it. It is what it is. Now, in C# we use the constant keyword to let them know, hey, that's a constant. I like using all capital letters in the name, so that when somebody sees it, they recognize, I know what that is just by the fact it's all caps. This author doesn't go by the same rules that I've gone with for decades now. So we've got this public class called test. It has within it a field that is public, so you can access it outside. Constant, it does not change and you can't touch it. It's of the data type string, and it has the name message. What value's in there? That string right there, that semicolon says we're done. Opening curly brace at the start of the class, you got to close it when you're done. These have to align. Every time you open, you have to close somewhere. And to adhere to best practices in your coding, you want them to align vertically. Same levels of indentation. So when you look at your code, a lot of times this opening curly brace could be sitting up here. Put your insertion point in front of it, hit enter. It will indent correctly and automatically. This will be indented in. From there, this will line up perfectly right below it. So when we look at it, we can see where it started, where it ended. There's no confusion about the fact that, yes, I've got my opening, I've got my closing. I can put white space in there as needed. Anything I need to keep the code itself, the structure of the code, clean. Always adhere to best practices with your code. Putting comments in, explaining what you're doing. White space to separate the code to keep it clean and in logical groupings, as well as the indentation to help you understand that every time you open the door, you closed it. This is a big hurdle for some people. I don't like using the word lazy, but if we're not clean about what we're doing, we run into problems. We get tripped up when we're laying stuff. Don't pick up things that may happen to be on the ground. Now, I said, hey, constant and this static read-only, they're similar. They're not the same. Constant is more restrictive. Static and read-only, they're not as strong a keyword as using constant or const. So here I've got public static, doesn't return anything. So I'm declaring a method. No, it does return something. Public, got to access the outside. Static, it doesn't change. Doubles what's being returned. The name circumference, it's receiving a parameter of the data type double. We're going to call it radius inside. And here it goes and gets system.math.pi. What's happening in here is the same every time we go to do it. What's different is what you pass it, but everything in here will be the same. It doesn't change. Pi will be the same today as it was yesterday as it will be tomorrow. And it's the equivalent of, here's that same line, but when we look here, it goes and gets pi and then puts it at the place that we invoked that statement. So this calls the system.math.pi field, says go get me that value and put it right here so I can use it. That's the equivalent of it here. This will be the same every time. The only thing that's changing is what we pass it to modify or change what's being output. The functionality is the same every time we do it. That value is going to be the same every time we run it. This one's a little bit different in that we're still saying static, read-only, date time, startup time. So with this, static, it's not changing. You can't touch it or modify it. Date time is what's getting returned. It's not really getting returned. We're using the date time class. And here we're calling this variable startup time. Now, it's in date time format. That is what startup time is. And it's going to have that value. So date time data type for startup time. And we assign it a value of whatever this thing returns to us. Now, every time I run this, it's going to be different. Every time I run it, it's going to be different. Now, it's going to go to the system clock and find out what now is and format that in datetime format. So date time is coming off of the system clock that you're using, and we format that value, data that gets returned, using the date time data type. That's the field associated with it is now. So that doesn't change. We can't touch it. There's a variety of different things that we can go through and do that this doesn't return anything. It's a method that we're creating. In here, we've got a constant double, we call it 2 pi, and there it goes. That value, 2 times pi, does not change. It's the same every time this runs. So now, we talked before, I gave you some reference material along with that second lecture that went with Module 2. Talk about in and out and ref. So we've dealt with parameters, passing values to the methods. They also return some data type as well, or they may not. We may have void. It's all keywords that we've been using. We've got access modifiers, whether it's static. There's a static modifier saying it's not changing. Your access to it. Everybody got access only internally. Is it private? Is it protected? Inheritance, new, virtual, abstract, override, sealed. So with methods, we've got some of the same things we saw above when we were talking about data types or classes, creating instances of a data type class, or creating a class, an instance of a class. Now we're dealing with methods. So when we're dealing with the methods, we've got different things that we can do, and we've got what we call local methods. And here's a method called write cubes that doesn't return anything. Up in the top of our code, we would have had using system. I would have preferred to say using system.console, but we had to be explicit here since we didn't do that. It's a console.writeLine, so we've utilized the console within the system to interact with the system console or command line interface. And the writeLine method takes whatever you pass it and displays it on the command line. Cube method that receives a value of 3. Well, what's the cube method? Well, we declared it down here. And the cube method, I said, well, integer value is a parameter that comes in. So we bring that value in, it's 3. It's going to return an integer, it receives an integer. So the 3 comes in, and we take that 3 and we plug it into this parameter, which is a variable inside the method, or a field inside that method. 3, and essentially we're saying this method is going to return the result of this calculation. That's what's happening here. So we perform a calculation, and then that's what gets returned. That's what we see here. That's coming from the chapter 2. So 3 comes in. 3 times 3 times 3, 27. 27 gets returned when cube is called and passed 3. We can do the same thing with 4, do the same thing with 5. So I defined a method within a method So here's a method declaration. Here's a method declaration. This one exists in here. It's local. I could have put it somewhere else, but they wanted it local for that example to show what's local and what's not. So the static modifier prevents the method from seeing the local variables and parameters of the enclosing method. So this one doesn't, let me back up, let's see if they've got a better example. They don't show it. Static would say, hey, this one can't see anything going on out here other than what's being passed to it. So it's kind of like it's encapsulating it with that keyword. So it's another way to hide, in a sense, something from something else. Or we don't want to, they say, accidentally refer to variables that may have the same name. We don't want to get caught up in that. So they talk about top-level statements and overloading methods. And when I'm overloading methods, essentially, I've got multiple methods with the same name that I've declared multiple times. I just wrote them differently with different parameters being passed to them. Now that way, I can have a variety of different people interact with that method, and different people may have different values to pass to it. I don't necessarily know what's going to get passed to the method. So I'm ready for anything. I'm ready for an integer. I'm ready for a double. And you want to pass me an integer and a float? How about a float and an integer? Either way, I'm ready for it, and I've written the method differently to accommodate each one. Still the same method, still does the same thing, just went about it in a different way. When we say we're overloading it, essentially what that means is we are using different versions of it to accommodate the different types of parameters being passed to it. Now, when we call it with something other than what it's ready for, it will then waterfall over, look to the next one, look to the next one. So it knows what it's looking for. There's things we can't do. Each one of these returns nothing. I can't do this. I can't say, all right, here's foo, it doesn't return anything. This foo returns something. I can't do that. I can't go about this, even though they're both void, I can't do it this way. I can't say that reference that we were talking about before, where there's params, ref, in, out. I can't do that kind of change. I'll end up with a compile time error. Okay. So if I'm going to overload it, I need to think about the fact that everyone's going to return a value in the same format or nothing at all. They're all going to, I can have multiple or different data types, but I can't have different refs along with it. I can't have the params modifier. So we see the same thing here with the out, the ref. That's not going to work. So I can't have those modifiers in there. I'm okay when I've said int and I went to ref, but the out's going to throw an error. So I talked about the constructor. So the way they word it here, constructors run initialization code on a class or a struct. All right, so can you reword that to make it a little simpler? Yeah, I can. What I'd said before was the constructor always has the same name as the class itself. Okay. Constructor, or I should say class, panda, constructor, public, panda, it's a method, and we pass it a string n, okay, n goes into name. So we've initialized or set up a field in the class, and it happens at the time that this object is being instantiated. So when I call panda and I pass it PD, this is calling the constructor. So I'm creating a new instance, instantiation, of panda, passing it PD. This new instance of panda has a name lowercase p, and I've specified that and it's an instance of panda. So I'm creating an instance of panda p. It's a new instance of panda. Didn't exist before. It's not like I'm modifying something that already exists. It's a new instance of panda. The class panda has a field name, and then here's our constructor method. So here's the instantiation where we call the constructor, and here's the class, the parent class that we are instantiating, where we're creating an instance of it. So instance constructors, that's our constructor right here, have access modifiers, public, internal, private, protected. There's unmanaged code modifiers, whether it's unsafe or external. And there's different ways to go about it. I can create this is a way to avoid being ambiguous, or they say disambiguate the name itself. So we're saying this dot name equals name. Now panda has a name. So what name? Here we create an instance of it. We said panda, and we're passing it whatever n is. Name equals n. So, whoa. Name's in here. I didn't need to do it this way. It's a kind of awkward way to do it in one statement, but I could do it this way. I can say this dot name, and there's the this refers to this object that I'm creating, the name field associated with it will get name, whatever's in name. So it's the way they've got it laid out. It's not the best example. I showed an example of overloading. I can overload a constructor. So here's an example of overloading a constructor. Let's say there's a constructor that doesn't require any parameters. It doesn't need anything. So if I created an instance of player, well, there was nothing that I had to use. Still, this is a wonky example. Here's an example of the constructor. It doesn't require any values. That's the better example of it. We're being explicit about it, and on this one, we're being implicit. It doesn't happen. We don't see it happen. Here, we're saying, yeah, here's the constructor. There's nothing going on in it. We're creating it. Deconstructor, essentially, when we're done with that object, here's how we essentially make it go away. It's the exact opposite, if you will, of the constructor. So we'll dig into this a little bit later. We're not going to dig deep into the deconstructor aspect of it in this module. If you want to use this in the task that I've got you doing in the constructor, that's fine to go explore with this. Okay. So I've got a class. There's a field, a couple more fields. Constructor, and here's a method. It's essentially what's happening in here. And in this, we have the ability to initialize values associated with our bunny object. I'm going to create an instance of bunny. I'll call it what I want to call it. And here's an instance of bunny called B1, another one B2. These bunnies have names. They walk through each one of them in different ways to go about instantiating them. Okay. So this reference, and we saw it above, it refers to this instance itself. So here's our class, public panda mate, public void Mary, panda partner, mate equals partner, partner.mate equals this. So when we look at it, the Mary method uses this here to set partner's mate field. Partner's an object, Partner came in, partner got passed in when Mary got invoked. So if somebody's called Mary, passed at partner, we're talking about this instance of the object itself, or instance of the class itself. So properties, they look like fields from the outside, but internally they have logic associated with them. It's like a method does. There's something going on there other than just some static value. So here's an instance of the stock class. That instance of the stock class has a current price, and I gave it 30. So I've initialized it with 30. Now here I've modified it by reducing it by 3. Console.WriteLine Microsoft.current price. We go get what's there. It's difficult to see whether we're talking about a field or a property, but still it's about the same. But one, we just went and put the value in there. The other, it got calculated and there's something that took place. One of the things that we'll deal with over and over again, and this is our ability to encapsulate what's happening inside our code, is using get and set methods. So I don't want anybody to actually be able to touch current price. So I've got this stock class. I'm going to create an instance of it. It has a current price field associated with it. Okay. But they're saying, wait a minute, this isn't a field, it's a property. Why is it a property? The fact that I'm hiding it. There's some logic going on back there that I don't want people to get to it directly, if you will. So I'm going to say, you know what? Here's decimal. It's public. It's current price. People have access to it, but not directly. I want them essentially to get access to it only through the get and set methods. Get returns current price. Set takes whatever we pass to it and puts that in current price. That allows us to encapsulate it and hide the things that are in there. So when I say public get, let's return current price times shares owned. That will get us the value of worth. Nobody can actually touch worth. All right. So this is where we talk about this is a property. It's a calculated property. It's not a field, even though conceptually it's similar to a field. It's different. got a variety of different properties. So in this one, I said, you know what? I'm going to define current price. It's a decimal, it's public, and there's going to be a set and a get associated with it. If you call get current price, it's going to give you the value. Set current price is going to give you the value. I don't have any value in there yet, but this is our way to protect whatever's going on. This initializes current price to a value of 123 or 123. Here we said, all right, let's create an integer. It's going to be public, has a name maximum. You can get it, but you can't set it, you can't change it. It is what it is. So people have access to it. It's initialized. Now, we have property accessor with init instead of set. So we had get and set. Here we have get and init. Okay. And here we have init only. It acts like it's a read-only. So it's, if you think about what happened back here, there wasn't a set, but it took place. This is implicit. This is being explicit. We're saying you can go get it, and we're initializing it at 20. You can go get it. It's being initialized at 100. If you try to change it, it's going to say, hey, we got a problem because you can't change it. You can't do an explicit access modify of it. So they say, wait a minute, it can only be init, initialized there. At the time that we create the note object, if I did this, there I could initialize it. I'm being explicit. Here I'm being explicit, and we know it's automatically going to happen. But here I'm overriding it, saying, look, I want pitch for this one to be 50. So we've got a lot of back and forth, different ways to access and change the values of different properties. Okay. So I've got init, set, get, and then we've got clear as well. All right. They talk about indexing, and we talked about it before to a degree, and we're talking about the index of a specific character in a string. We'd seen this in Module 2. Break off of this one, and we'll pick back up on lecture 3-2. I don't want them to be too long, so I'll do this one in multiple parts. I'll see you in the next portion of the lecture.